Okay, the next part from chapter 9 is how to find the determinant of a matrix in our calculator. Now first, in order for this to happen, to be able to even find a determinant, which is just a real number associated with certain types of matrices, and for you to have a determinant, the matrix must have the same number of rows and columns. It's called a square matrix. So like this has 3 rows, 3 columns. Okay, so first thing we're going to do is go back into our second matrix and just put these numbers in there. Okay, so let's see, second matrix. Slide over to edit. We want to change the size. This time it is a 3 enter by 3 enter. Okay, now we're going to type in the numbers. 1, 2, 0, 3, -1, whoops, -1 enter, and 2 enter, and then 2 enter, 0 enter, 1 enter. Double check all your typing. -1, 0, 0, 2, 1. Okay, and again, second quit. Okay, now we want to go back into our second matrix under the math command, but this time we want the very first one. It's an abbreviation of the word determinant. That is the only part that changes. Okay, so second matrix math determinant number 1. And again, just like before, we have to put the name A there. So second matrix, name A. So press enter. Pop it up right behind it, and then one more enter. Okay, and the determinant is 1. It's not a matrix answer. It is just a real number. Very, very easy. Okay. Alright, so here are 6 of them for you to try right quick. On the next page, you will have the solutions. So hit pause and work them out, and then look at the answers on the next page. Okay, so here are your answers to those determinants. Take a minute, check those, and hopefully you got them all correct. Alright, now moving along, the third idea, there's going to be 4 ideas that we learned. So the third idea now, I'm just going to clear my calculator over there, is how to graph an inequality, a single inequality in our calculators. Alright, so first thing we have to know is if we've got something like this and the y is not by itself up front, first thing we got to do is get that y by itself. So that's just using your old Algebra 1 stuff. 6x plus y greater than 7, I would subtract the 6x, and what I do on one side I would do on the other. So y will be greater than 7 minus 6x, or negative 6x plus 7, just whichever way you prefer to write it. Okay, and so then we're going to go to our y equals. We're going to type in whichever of those two you choose. I went with this one when I typed it in. Okay. Now, notice right now, if we were to hit graph or zoom 6, this would just draw a straight line, because that's y equal mx plus b. Well, remember, we're wanting to graph where the y's are greater than that expression. So, over here on the left of y1, something you might have noticed before, but we haven't done anything with it. But if you press your left arrow, okay, I'll do it over here on the calculator. Okay, let's clear. Alright, so I've got my negative 6x plus 7. But I don't want it to do equal, so I'm just going to slide my left arrow. Now, most of you will have just the plain. You can see on mine that I've got up here, it's got a color and the mark. Over here for y'all that just have the mark, you will simply press enter slowly until you see the upper triangle, darkened triangle. Looks like this. I think it's the second one, and then the third one I believe is the less than, pointing down. Okay, and you'll just leave it sitting there if you don't try to hit enter again, because that'll flip you to the next symbol. If you skip it, you just cycle back through. There's 6 or 7 symbols, so just cycle back through, pressing enter, enter, enter until you get back around. We want the upper shaded triangle. That means greater than. Now, those of you that have this kind, when we press enter, it's actually going to open this up. So you get to decide, you get to choose what colors you want. Oh, I'm used to using the cursor. Oh, but I actually have to press just like y'all would. You know, press the little arrows, several different shades of gray. So whatever color you want it to do your shading. I'm just going to leave it back on, where did I have it a minute ago? That blue right there. Now, down arrow, and again, left or right arrow, gets us to those same little triangles. So the first time I click it, that triangle is for greater than. If I clicked it again, that would be less than. Now, on this kind, we can actually go backwards. So I would just go backwards if I skipped over it. But you could also just enter, 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 and it'd get back around to it. So I'm putting this for greater than. Then I'm going to go down arrow and enter on the word OK. And so now over here, let me move that. Up there you can see you have got the triangle. Okay. So you've either got the upper triangle and a color, or you just got the upper triangle. Okay. Now, just like always, we're ready to look at the graph, so we will press our zoom 6. It should graph it between -10 and 10 in each direction. And it's shading, so it's saying all of these points that are over here are where the y's are, or they're where 6x plus y is greater than 7. Now, one thing that the calculator does not do, the calculator does not show us what kind of edge. So if you have just the less than or the greater than, it's a dotted or a dashed edge. If you've got or equal to, you've got the solid edge. And so you cannot do that on the calculator. You would simply be, like on your paper, you would be sketching. On this one, we've got the dotted. And then putting like your 2 arrows. If it were a multiple choice answer in the computer where you were trying to choose, you just got to be sure that you're looking and thinking about that edge and choosing the correct edge. And so again, what it means is that all these points, all the way out forever and ever, down, up, and to the right of that dotted line, would have ordered pairs that make 6x plus y be greater than 7. Just that simple. Now, on a system of inequalities, still going to start out that we have to first solve for y in both equations. So let's do that. X plus y is greater than or equal to 6. So I'm trying to get the y by itself, so I'm going to subtract the x, subtract the x. Y needs to be greater than or equal to 6 minus x. Then over here, if I subtract my 2x, subtract my 2x, because we always want the y to stay left of the inequality. So now it's saying negative y is greater than 3 minus 2x. We need to divide by this negative 1, And remember what I've got right here in the little box. If you multiply or divide by a negative number, you must reverse the inequality symbol. So it's no longer going to say greater. It's going to say y is less than. And all of these get divided by -1. So -3 plus 2x. So I'm going to have down here, I'm going to be typing the greater than 6 minus x right there, the less than -3 plus 2x. Remember, you cannot type in the difference between whether or not it has or equal to. You'll just have to be thinking about that at the end. So let's go over here. I'm going to clear out the old. Okay. I need a greater than. So greater than right there. Okay. And that is for the 6 minus x. And then I'm going to go over there to the left. And I need the less than. I don't think I'll do it in red. I'm going to do it in green. Okay, and now I want to go down and grab the less than. Ah, shucks. I keep forgetting about switching between the cursor, the mouse that's in my hand, and using these symbols up here. Okay, so I'm down on this. Right arrow, right arrow. So less than. And then okay. Alright, and I'm typing in -3 plus 2x. -3 plus 2x. Okay. I'm going to graph it on Zoom 6. And this time for a system, the solution to the entire system is only where the two designs are overlapping. So it's not all of the colored part along the way. It is only where they are overlapping. Okay. So I'm going to try to push that up a little bit. Okay. So not here, not any of this. Now I've got to figure out, because one of these is a solid line and one was going to be a dashed line. This one, the equation that came from this first one, had the solid edge. So let's see, that was the 6 minus x. That was the one coming down. So I'm going to go in black ink. Okay, so right along here is solid. The second one, see, it just said greater, so that's the dotted edge. And then, again, only the overlapping, so in between those and going out that way is the solution. Okay. Let's see. Okay, and one last example of a system. Now notice this has two regular ones, like what we've been doing with the x and the y. But then it's got x is only greater than or equal to 0, and it's got y's greater than or equal to 0. Okay, well remember what the button says that we use to graph. It says y equal. It doesn't say anything about an x. So we cannot graph x greater than or equal to 0. Okay, we can adjust for it at the end, but we can't graph it. So I am putting in, okay, and again I've got to solve these, first of all for the y, both of these. Okay, so I type in the 4 minus x, it's a less than. 6 minus 2x, it's a less than. And then I can even go ahead, because it is the y, I could put the y equal to 0. And I can go over there for greater than and put the upper triangle. Okay, for y greater than or equal to 0. Okay, so in that case, let's go now in order to get the x part. The x part, we go to our window to take care of that. It said the x's need to be greater than or equal to 0. So I start the minimum at 0 and go up to 10, you know, just from our standard number. Minimum. X's, if I'm going from count from 0 to 10, those x's are greater than or equal to 0. The y's, also I go ahead and adjust. Even though I've got it up there, I'm also going to go ahead and adjust. It said y is greater than or equal to 10. So the same reasoning. That means they're 0, 1, 2, 3, 4, 5. So I'm putting them 0 to 10. Now remember, whenever we do that, that's when we always hit the word graph. Okay, and it should look like this. And so we want to remember the x-axis is the bottom boundary, because you might be picking it off of a graph like on a multiple choice answer that looks like this. And so you would be looking, you know, just right in here is where they're all overlapping. And I think on this one, if I look back up, they were all solid. They were all or equal to. Okay, so that's how your solution would look right there. All right, and that finishes up all of the Chapter 9 material.